this is Jo from Math Tutor Me. Today we're doing measurement and we're going to look at some harder perimeter questions. Hopefully you've already joined me for our first lesson on perimeter so that we can do this harder lesson today. So to make perimeter harder, there is two things that we can do at this stage. So the first thing that we can do is we can have different units. We might have centimetres and metres in the same question. So you'll need to make sure that your units are the same before adding your sides together. Okay, so that's one way to make it harder. The other thing that you may need to do is you may need to use Pythagoras Theorem to find some of the missing sides in some triangles. Okay, so this is a reminder here. Pythagoras Theorem is c squared equals a squared plus b squared. So to do this lesson today, hopefully you have done Pythagoras Theorem before. If you haven't, you'll need to look at the lessons on Pythagoras Theorem first, and you can find those on my website. Okay, so let's have a look at the examples. Number 1. A carpenter measures a rectangular table to be 1.8 metres long and 90 centimetres wide. Find the perimeter of the table. So if you like, you can draw a diagram. It's always good to have a visual of what you're trying to do. So it's 1.8 metres long and 90 centimetres wide. Okay, so that's the little trick with this question. One of my measurements is in metres and the other one is in centimetres. Now, you just need to make sure they're the same. You can choose whether you want them both to be in metres or both to be in centimetres. I usually prefer to get rid of the decimals where possible, so I usually change into the smaller unit. So I'm going to change mine into centimetres. So 1.8 metres, you would times that by 100 to get 180 centimetres. Because it's a rectangle, this one's going to be 180 and this one's going to be 90. So the perimeter is going to be equal to 2 lots of 180 and 2 lots of 90. Equals 180, whoops, turn the calculator on, 180 times 2 plus 90 times 2. Okay, don't forget to put centimetres at the end of that. Okay, question 2, to find the perimeter, we only have two sides, but we have a right angle triangle and we can use Pythagoras Theorem. So before we do anything on perimeter, let's do Pythagoras Theorem. We're finding the hypotenuse, so we use c squared equals a squared plus b squared. These are my two shorter sides, so I'm going to let a squared equals 6.3 and b will be 9.1 squared for both of them. Okay, then I'll use the calculator. 6.3 squared plus 9.1 squared equals 122.5. Now to get rid of the c squared that we have here, I will need to square root 122.5. And that is equal to 11.1 if I stick to one decimal place. These ones are in one decimal place, so we'll just stick with that. Okay, so this side is 11.1 centimetres. So now I have all three sides, I can find the perimeter. Perimeter is equal to, let's start with our hypotenuse, 11.1 plus 9.1 plus 6.3, which will give me 26.5 and the units centimetres. Alright, let's look at question 3. I have, it almost looks like a square, but we can't completely write that that will be a square. It is at least a rectangle, so we know if this is 15.1 that this is 15.1. And we have a little triangle up here, so we have the hypotenuse and a shorter side, so we can use Pythagoras Theorem to find this other shorter side here. So the shorter side formula is b squared equals c squared minus a squared. It's just rearranging this formula. So we start with the hypotenuse, which is 13.7. That will be squared. And then we subtract the shorter side that we have, 4.6 squared. Let's calculate that. 13.7 squared minus 4.6 squared equals 166.53. Now this is still b squared, so we will need to square root that number in order to find b by itself. So the square root is equal to 12 point, now we've got have one decimal place here again, so let's go 12.9, one decimal place, centimeters. So it's not a square, it is definitely a rectangle. This side here is 12.9, which means that this side is 12.9. Now this one here won't actually count in the perimeter, but it helped us find this one down here. So now let's write down what our perimeter is equal to. Let's start at the top and go around in a loop. We have 13.7 plus 4.6 plus 15.1 plus 12.9 plus 15.1. Okay, 13.7 plus 4.6 plus. So our final answer for perimeter is 61.4 centimeters. Okay, so here are 3 questions for you to try. So pause the video, give these questions a go, and then restart to see the answers. For question 1, we have 3 side lengths here that are all in different units. Now you can choose which one you want to change them into. I might choose centimeters this time. So I'm going to leave this one as 140. I'm going to change 800 millimeters. To change that into centimeters, I would need to divide by 10. So that's going to give me 80 centimeters. And 2.1 meters, to change that into centimeters, I need to times by 100. So that will be 210 centimeters. When they're all in the same units, then we add them all up. Perimeter is equal to 140 plus 80 plus 210. 140 plus 80 plus 210 is equal to 430 centimeters. If you had changed it into meters and got 4.3 meters, that's the same answer, so you're still correct. Okay, question 2. We have 2 sides of the triangle, and we need to find our third one in order to do the perimeter. So this is the shorter side of a right angle triangle, so we're going to have to use the b squared equals c squared minus a squared version of Pythagoras' theorem. So finding the shorter side, b squared, c is the hypotenuse, 12 squared, minus the other shorter side here, 10 squared. On the calculator, 12 squared minus 10 squared is 44. Now we need to get rid of this squared here, so we need to square root 44. The square root of 44, let's do one decimal place, is 6.6. So this side is 6.6 meters. So now that we have all the sides, we can find the perimeter. Perimeter is equal to 12 plus 10 plus 6.6. 12 plus 10 plus 6.6. Oops. 28.6 meters. Okay, question 3. I have 2 triangles on top of each other here. Now this side is not important for the perimeter, but I'm actually going to have to find that side in order to find this one. So I use this triangle and I do Pythagoras' theorem to find this one, and then I'll have to use Pythagoras' theorem again with these 2 sides to find this one that I need on the outside here. Okay, so this side is the hypotenuse, so we're going to use c squared equals a squared plus b squared. Okay, my two sides are 11 and 18, so we'll go 11 squared plus 18 squared. So that makes 11 squared plus 18 squared, 445. And to get c by itself, we have to square root it. Square root of that is 21 point, rounding that up will become 21.1 to one decimal place. So 21.1 goes there. Now, we need to use Pythagoras Theorem again, and again it's the hypotenuse. So c squared equals a squared plus b squared. This time it's 7 squared and 21.1 squared. 7 squared plus 21.1 squared is 494.21. That's the c squared. Still have to square root it. Which is 22.2. That's that one. Okay, now we have all the sides around the outside. As I said, this one won't count. So the perimeter is equal to, let's start with our 22.2 and go around. We have 18 across the bottom, 11 and 7. Adding them all up, we get 58.2 centimetres. There it is. Hopefully you followed along with that. Hopefully you got all those answers. So that's it for today, and I'll see you next time. Bye.